Well, it's time to look at the constructive versus destructive forces when thinking about our landforms. And this is important information because you're going to need to know this in order to do well on your project. So you have your Venn diagram page, and it's important to know that landforms around the world are made by either constructive or destructive forces, or sometimes both. So in order for you to do well, you're going to need to be able to first know what these forces are, constructive and destructive, what they are, and then how plate movements, different plate movements, create these constructive, destructive forces, or both. And this is going to be very, very helpful for you. So I hope that you keep this handy when you're doing your project. So, without any further ado, let's roll. All right. So, in the Venn diagram here, this circle is going to be constructive, this circle is going to be just destructive, and then as you are well aware with Venn diagrams, the things that they share, right, go down the center. All right, so first up here we're going to write constructive. Up here we're going to write destructive. Okay, and then our first task then is just to quickly kind of describe what are these two. What do we mean when we say constructive forces or constructive forces? What does it mean when we say destructive forces? I'm sorry, I'm wearing a mask all day, and then taking it off to do the video, I feel like I got little mask fuzzes all over. So if I keep doing this or taking stuff off my face, you know, that's why I feel mask fuzzes everywhere. Okay, so constructive forces, what are these? Okay, these are forces that work to build up new crust or build up new land, like a new landform, that one that wasn't there before. Okay. If it weren't for these forces, you just have a level ground, right? But because these forces are at work, you get the buildup of new land or new landforms, or you make new crust. Okay, those are all the results of constructive forces. Okay, now an example of this. Okay, what type of plate movements generate just constructive forces, or are the result of constructive forces rather? Well, whenever you have plate movement that creates uplift, you're going to get new construction, new land, new crust. Well, what is uplift? It is the buckle to buckle upwards. It's the buckling upward of new crust, new land, okay? So what you end up kind of getting here is you end up kind of, because of these forces, you end up getting mountain ranges, or you end up getting volcanoes, or you end up getting anything that is pressed and pushed upward, right? Because of some type of, usually it's compression, usually it's from the side, but you could also get uplift from forces underneath. Okay, you can also get that. Okay, so uplift can be caused by these types of force directions, but it always results in the building up, right? The buckling upward, the building up of new crust and new land. So uplift is always associated with constructive forces. Now, what about destructive? Well, it's kind of the opposite. Okay, it is the tearing down or to break down of old crust or old land. Okay, so crust or landforms that were already there are being torn down, or being worn down, or being crushed, being remelted back into the earth. Okay, that type of thing. Okay. So if existing crust is being torn down, broken down, those types of things. Now typically, typically there's one of these motions that is associated only with destructive forces, and that is subduction. Okay? Now what does subduction mean? Sub means to go under, right? So when subduction occurs, the more dense plate is actually going to be driven under the less dense plate. Sorry, that should say less dense plate. Sorry, make sure you put that over there. And this drawing here, we've done a lot of. Okay, so this is one that you've seen. So you've got one plate. Okay, you've got one plate because it is more dense as they converge. You have the more dense plate being driven down underneath the less dense plate. And because of that, this plate here, the tip of this plate that's being driven back down into the asthenosphere, okay? And I'm going to let purple represent the asthenosphere here. So again, our crust is lithosphere, okay? Well, this is getting driven back into the asthenosphere. There's great heat, there's great pressure there, and it's tearing down, breaking down, and melting down old crust. It's turning it into new asthenosphere or new magma that later, somewhere else on some volcano somewhere, will be re-erupted back out onto the surface of our planet to create new crust. So right now, this old crust is being reconsumed in subduction. But later, it will be returned to the surface of the Earth and thus recycled, right? Consumed here, but then produced somewhere else as new crust. Okay. Now, there's one more little thing here I need to remind you of, and it's this part right here, especially if this takes place underwater. If this takes place underwater, what you get is a landform that is made by this subduction, and it's called a trench. Okay, and where is this trench? This dip in, this depression made where one plate is being driven under and it's grabbing the edge of the other plate and making this narrowing, this almost like a ditch, very deep groove cut right here. And it's just what would be the ocean floor right here. That would be where the ocean floor is. It's being pulled down and the ocean floor is getting deeper and deeper and deeper and deeper and deeper. That's a trench. Okay, so I'm going to kind of draw an arrow to where this trench is. Okay, if you know where the trench is, you don't need to draw that arrow, but that's where the trench, that's the trench, and that's where it's located. Okay, so we've got some things that are basically strictly constructive. We've got some things that are basically strictly destructive. But then we've got, like in most cases, you're going to get a landform, right? And it will be the result of maybe some constructive and maybe some destructive. So let's break down the center here. What things belong in constructive and what things belong in destructive? Both. Okay, because there's elements of both in a lot of these. So let's start with, we've talked about uplift, we talked about subduction. So we've got 4 of our movement terms, our vocabulary terms left to talk about. So typically, right, you're gonna talk about convergent boundaries. Okay, so what happens at convergent boundaries? Well, some constructive and some destructive. So let's talk about it in detail. Well, what part about converging boundaries would be constructive? What part of this is building up new land? Well, if you have that works. If you've got subduction you've got that pulling down, that's for sure, but eventually over here on this less dense plate, you're going to get that buckling upward. You're going to get this uplift. So while you are destructing old crust down here back into the asthenosphere, that's true, you're also getting the land over here to buckle upward and be forced upward to create this new landform, a hill, a mountain, a volcano, whatever you have over here. Well, there's your constructive and there's your destructive. So what's constructive about convergence? Well, you get uplift. You get uplift at convergent boundaries. That's constructive. That's the result of constructive forces. But at convergent boundaries, you also will get, even if it's just a little bit, you'll still get subduction here at these boundaries. So what is destructive? Subduction. Okay, so at convergent boundaries, things that are made from convergent boundaries, right? If we're talking about the mountains, those are going to be made from uplift, but uplift from what? Well, you don't get this uplift if these two plates aren't converging and you get subduction here. So these mountains, yeah, they're an example of uplift, but this plate doesn't buckle up unless this plate is subducting under it. So you've got uplift, which is constructive. You have subduction down here where this plate is being reconsumed in the asthenosphere. That's your destructive forces, result of destructive forces. So that's convergent boundaries. Well, what happens if you have a landform that was made by a divergent boundary? Okay, well, you've got some constructive and you got some destructive there too. Okay, with diverging boundaries, you have constructive because just like in that mid-Atlantic Ocean ridge, which is an example of a divergent boundary, whenever you have that crust separating, you're going to have magma from underneath come in and fill those gaps and erupt and create new crust, whether it's on the ocean floor or whether it's on the ground. Whenever you have two plates that are separating, doesn't matter where they are, most likely you're going to have a asthenosphere coming up through that crack and having these small or large volcanic eruptions, and you're building new crust there in those gaps where the plates have torn apart. So what's constructive? You actually have that volcanism, or the act of volcanic eruptions. Okay? That's actually constructive. Now, it might be what we might use the words, it might be destroying lives and property, and that's very true, and that could happen, of course. But in terms of building up new land and new crust, volcanism is actually seen as a constructive, the result of constructive forces. Now, obviously, then what would be destructive about a divergent boundary? It's that tearing or ripping apart, ripping open that old crust to allow that volcano to do what it does. So for divergence, it's that cracking and tearing open of the plates at that boundary. That's destructive. Okay? So we have convergent boundaries, we have divergent boundaries. What about transform boundaries? Sure. There's convergence and divergent, or there's constructive and destructive forces happening around transform boundaries. Sure there are. Now, when you think about transform boundary, you probably think about the most popular example, the most common example, which is the San Andreas Fault in California. So let me show you a picture of this fault, and you'll get an idea about why we'll see some constructive and some destructive examples in this transform boundary. So let me move me. Let's get out of here. Okay, here's a picture of the San Andreas Fault. Okay. Now, remember, San Andreas is a transform, so these plates are sliding past each other, grinding slowly and catching and then ripping and catching and ripping as they slide past each other. All right. Now, right in through here, of course, is that boundary. This is one plate. The other plate's over here. Okay. So right here, very clearly, you can see that boundary. But is the land on either side of the boundary flat? Not generally. So these forces that are stressing and straining these plates in opposite directions are actually having a bit of an uplift effect. It's kind of twisting and buckling either side upward. So at transform boundaries, you can actually get some uplift. So at transform boundaries, you can have some uplift, and that definitely is constructive. Now, is it a whole lot of uplift? Are you going to get 7,000, 12,000 tall mountain ranges? Probably not. But you're going to get some, as you saw in that picture, you're going to get some uplift there that's going to create something that's not flat ground. So you do get a little bit of uplift there to transform boundary. But of course, you have that ripping and that tearing and that sliding past and catching and then releasing violently. You have those types of actions at a transform boundary. So the ripping, right, and the tearing across and along that boundary, that's definitely destructive. Definitely destructive. Okay, so then the last thing that we're going to talk about is a hotspot, and then we're done. So a hotspot, what are we going to have here? We're going to have constructive and destructive? Absolutely. You are reminded, right, of what a hotspot is. You have the plate, and you have a hotspot underneath the plate. The hotspot works its way through and develops a crack in the crust, and you have volcanic eruptions that continue and continue and continue, and you build new land. Well, the hotspot stays in one place as eventually that plate shifts and moves. The plate moves, the hotspot generally stays in one area. So this one mountain here is done being built, and the plate moves, and now you have a new section of plate over the hotspot, and the hotspot begins its work again. And then the plate moves again, and now you're going to have even more island building. So you have this succession of islands being built over the hotspot. So I just used the word built, so probably we're going to get some constructive results here. So the building, right, the building of new land, that's definitely constructive. The building of new land is definitely constructive. But the breaking through, the melting down and busting through the plate and breaking and cracking open so that this volcanic island can be made, that is destructive. That's destructive. So the breaking through, the crust, that is definitely destructive. Definitely destructive. You can't have this island or this volcano being built without first breaking through that, punching a hole through that crust and getting that volcanism going. Okay, so this is the important stuff that you need because when you're doing your project and I ask you, okay, here are the Andes Mountains, how were they formed? You can answer that question just fine by research. But when I ask you, okay, were the Andes Mountains the result of constructive or destructive forces or both? Now you can look through here after you've discovered what type of plate motion made those mountains. You can go in here and look up that plate motion and go, oh yeah, it was actually made by both, right? Or it was made by one or the other. Because here is your resource. Here is what you can use to help you get the good information that you need for your project. So I wish you luck. And I hope to see some really great projects, and I hope that this helped you in order to gain good ideas and good perspective for your project. So good luck.